All right, I didn't leave you a lot of space for showing your work on all of these, so I'm going to scroll down and do each one further towards the bottom. I hope I left you enough space on your paper. If not, you may want to use a separate sheet. Okay, so let's look at this first one. It says 4 to the negative second power. So because I have that negative 2, I'm going to rewrite it as a reciprocal with a positive exponent. So I get 1 over 4 to the positive second power, which is 1 over 4 times 4. So my final answer is 1/16. Okay, on number 2, I'm going to try to use different colors since I'm writing all over the place here. Number 2, again, it has a negative exponent, so I'm going to rewrite it as a reciprocal with a positive exponent. So don't get confused about that negative that's with the 2. That stays a negative. But the exponent, when you move it to the denominator, becomes a positive 5. So now I've got to multiply negative 2 times itself 5 times. 3, 4, 5. Okay. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. And positive 16 times negative 2 is negative 32. So that's going to be 1 over negative 32, or if you want, you could just write the negative out in front of the fraction like that. All right, number 3. Let me extend the page here. Whoops, a little too much there. Okay, number 3 is 6 to the negative 8th power times 6 to the positive 8th power. We're multiplying. Both numbers have a base of 6. Therefore, I can add the exponents. So I get 6 to the power of negative 8 plus 8, which is 0. And I know that any number raised to the power of 0 equals 1. So the answer to number 3 is 1. All right, number 4. Negative 3 to the 5th power divided by negative 3 to the 6th power. I am dividing. I have the same base number, which is a negative 3, so I'm going to subtract the exponents. That's negative 3 to the 5 minus 6, which is negative 1. So I get negative 3 to the power of negative 1. Now, remember, you can't have a final answer with a negative exponent, so I'm going to write that as the reciprocal of 1 over negative 3 to the positive first power. And raising a number to the positive first power it's just that number. So really what ends up happening is I get 1 over negative 3, or negative 1/3. Doesn't really matter how you write that final fraction as long as you know that it is a negative number. Okay, number 5 is a bit tricky. So I'm hoping that you do this one with me no matter what. We have 1 over, I'm rewriting it because I don't have enough space, 1 over 5 to the 7th power times 1 over 5 to the negative 4th power. We've got a lot going on in this one. We've got division because we've got the fraction symbols. We've got multiplication. We've got a positive exponent. We've got a negative exponent. There's a lot going on there. And there are multiple ways to approach this problem. But what I would probably do first is get rid of that negative exponent. Now, we haven't talked about an example of what you do when you have a fraction and the exponent is negative in the denominator of the fraction. I believe there was one like that in the Khan Academy example, but what ends up happening is that if you find the reciprocal of that number, the fraction basically flips over. just like when you learned about dividing fractions, it ends up being a multiplication problem by the reciprocal. All you're doing is flipping the fraction. So when I flip the fraction to get rid of that negative exponent, it becomes 5 to the positive fourth over 1. Okay, so that got rid of the negative. So now I'm going to go ahead and multiply. 1 times 5 to the fourth equals 5 to the fourth. 5 to the seventh times 1 is 5 to the seventh. So I still have division. Now I can subtract my exponents. 4 minus 7 is negative 3. So I get 5 to the power of negative 3. I'm almost done, but I can't leave an answer with a negative exponent. So let me just draw the arrow here. So 5 to the power of negative 3 is the same thing as 1 over 5 to the positive third power. And now I can simplify that. 5 to the third power is 5 times 5 times 5, which is 125. So my final answer is 1 out of 125. Wow, that was a lot of work. Okay, last one. And I really ran out of room, so I'm going to rewrite it down here. 4 to the fifth times 4 to the negative third. Let me give myself some more space. 4 to the fifth times 4 to the negative third power over 4 to the second power. All right, once again, I've got a lot going on in this one. I'm going to start with just the numerator, which tells me that I can use the product property and I can add my exponents because I'm multiplying and they're both 4 as a base. 5 plus negative 3 is 2. So my numerator becomes 4 to the second power. All I did was add the 5 and the negative 3. And now I'm rewriting my denominator. So now I'm dividing, which means I can subtract my exponents if the bases are the same, and they are. 2 minus 2 equals 0. So I get 4 to the power of 0. Anything to the power of 0 equals 1. I did it. Let me scroll up if you went to the end of the video to check your work. So the answer to 1 was 1/16. 2 was negative 1 over 32. 3 is 1. 4 is negative 1/3. 5 is 1/125th. And 6 is 1.